Hey, this is Teacher Riza, and this is our lesson 2 for week 1 in statistics and probability, the probability distribution of discrete random variables. Our learning competencies for this topic: find the possible values of a random variable and illustrates a probability distribution for a discrete random variable and its properties. In our previous lesson, we learned that discrete variable as a quantitative variable whose value can be attained through counting. And discrete random variable is one which may take on only a countable number of distinct values such as 0, 1, 2, 3, and 4. Discrete random variables are usually, but not necessarily, counts. An example of discrete random variables are the number of children in a family, the Friday night attendance at cinema, the number of patients a doctor sees in one day, the number of defective light bulbs in box of 10, and the number of heads flipped in 3 trials. We also discussed in our previous lesson as random variable is a quantitative variable whose value is dependent to the outcome of a well-defined random event or experiment. And the set of all possible outcomes in experiment is called sample space. Possible values of random variables are values that are obtained from functions that assign a real number to each point sample space. Example of random variable V, wherein V is the marital status of teachers. The possible values for this is single, married, and widow. For random variable W, wherein W is the number of dots after rolling a die, the possible values for this is 1, 2, 3, 4, 5, and 6. For random variable X, wherein X is tossing a coin, the possible values is head and tail. For random variable Y, wherein Y is tossing 2 coins, the possible values is head, tail, head, tail and head, and tail, tail. For random variable Z, wherein Z is household pet being raised, the possible outcome is dog, cat, mouse, and rabbit. Example of probability distribution is if a basketball team will play for 3 consecutive games, the sample space is the set of all possible outcomes of the events. If W stands for a win and L stands for a loss, the possible sample space of the results of the 3 consecutive games is we have for 3 consecutive games, first game is win, second game is win, and third game is win. So the number of win is 3. And second possible outcome will be win for the first game, win for the second game, and loss for the third game. So the number of win here is 2. And third possible outcome is win, lost, win. And the number of win here is 2. Fourth possible outcome is lost, win, win. So the number of win here is 2. Fifth possible outcome is win, lost, and loss. So the number of win here is 1. Sixth possible outcome is lost, win, loss. So the number of win here is 1. And 7 possible outcome is lost, win. So the number of win here is 1. And for the 8th possible outcome is loss for the first game, loss for the second game, and loss for the third game. So the number of win here is 0. So there are 8 possible outcomes, and the sample space for this is 0, 1, 2, 3, which is the number of win. Now, let's try now to find for the value of x, wherein we let x the number of win. Then, get the value of x. So, we have for winning 3 in 3 consecutive games is only 1. So x now is equal to 1. And winning 2 games in 3 consecutive games, there are 3. So therefore, the value of x is 3. Winning 1 out of 3 games, so that is 3, wherein the value of x is also 3. And 0 win for 3 consecutive games, we have 1. So the value of x is equal to 1. Now, let's try to find the probability, and that is p of x. For 3 wins, which is only 1, so that is 1 out of 8 possible outcomes. So therefore, the probability is 1 over 8. In winning 2 games, wherein we have 3 and the value of x is 3, that is 3 out of 8 possible outcomes, so we have 3 over 8. In winning 1, there are 3, so x is equal to 3, so therefore that is 3 out of 8 possible outcomes, so that is 3 over 8. And for 0 win, which is 1, wherein x is equal to 1, that is 1 out of 8 possible outcomes, so that is 1 over 8. So therefore, the probability that the team will win in all 3 games is 1 over 8. Now, let's try to find the sum of all the probabilities. That is adding 1/8 plus 3 over 8 plus 3 over 8 plus 1/8, and that is equal to 8 over 8 or equal to 1. So therefore, the sum of all probabilities is equal to 1. Consider now tossing 4 unbiased coins. Let's try to construct its sample space, assign possible values to the sample points, make a probability distribution function for getting ahead, then last we're going to construct a histogram. So these are the possible outcomes, wherein the first possible outcome in tossing 4 coins, all coins are heads. For second possible outcomes, we have 3 heads and 1 tail. So therefore, there are 16 possible outcomes in tossing 4 coins. For the first possible outcome, we have the number of heads as y is equal to 4. For the second possible outcomes, we have 3 heads. For third possible outcomes, we have also 3 heads. Fourth possible, we have 2. For the fifth possible outcomes, we have 3 heads. 6 possible outcomes, we have 2 heads. 7 possible outcomes, we have 2 heads. 8 possible outcomes, we have 1 head. 9 possible outcomes, we have 3 heads. 10 possible outcomes, we have 2 heads. And 11 possible outcomes, we have 2 heads. 12 possible outcomes, we have 1 head. 13 possible outcomes, we have 2 heads. And 14 possible outcomes, we have 1 head. 15 possible outcomes, we have 1 head. And the 16 possible outcome is 0 head. So therefore, there are 5 distinct possible values of y, wherein y is equal to the number of heads, that is 0, 1, 2, 3, and 4. So from the number of heads, we're now going to get the probability, and that is p of y. For getting 0 head, we have only 1. So that is 1 out of 16 possible outcomes. So that is 1 over 16. For number of 1 head, so we have 1, 2, 3, and 4. So there are 4 possible outcomes in getting 1 head. So that's 4 out of the total possible outcome, which is 16. So that's 4 over 16, or reducing that, that is 1 over 4. And for getting 2 heads, so we have 1, 2, 3, 4, 5, and 6. So there are 6 out of 16 possible outcomes. So that's 6 over 16, or 3 over 8. And for 3 heads, we have 1, 2, 3, 4. So there are 4 out of 16, so that's 4 over 16 or 1 over 4. And for getting 4 heads, so we have only 1 out of 16. So we have here the number of heads and the probability of PY. Now let's try to find the sum of all the probabilities. That is adding 1 over 16 plus 4 over 16 plus 6 over 16 plus 4 over 16 plus 1 over 16, which is equal to 16 over 16, or that is equal to 1. So therefore, the sum of all probabilities in the discrete probability distribution is always equal to 1. Always remember that. And to make an histogram, wherein histogram is a bar graph but has no spaces in between the bars. So we have here the histogram. For horizontal line, we have the number of heads, which is y, which is 0, 1, 2, 3, 4. And for the vertical line, we have the probability of P of y, that is 1 over 16, 4 over 16, and 6 over 16. In probability of getting 0 head, that is 1 over 16. In getting 1 head, that is 4 over 16. In getting 2 heads, that is 6 over 16. In getting 3 heads, we have 4 over 16. In getting 4 head, that is 1 over 16. So from the histogram, we're going now to try to answer the following question. The first question is, what is the probability of getting more than 3 heads? Getting more than 3 heads means getting 4 heads. And the probability of getting 4 heads is 1 over 16. So therefore, the answer is 1 over 16. For second question, what is the probability of getting less than 2 heads? Less than 2 heads is getting 1 head, which is 4 over 16, and less than 2 head is also 0, and that is 1 over 16. So therefore, that is getting 1 or 0. And the probability is 1 over 16 plus the probability of getting 1, that is 4 over 16. Adding 1 over 16 plus over 16, 4 over 16 is equal to 5 over 16. So the probability of getting less than 2 heads is 5 over 16. So for your activity, you're going to construct the probability distribution. For this problem, a cat gave birth 6 kittens. 3 of them are male while the rest are female. If you are to be given 3 of these kittens at random, list all the possible elements of the sample space using the letters M for male and F for female kittens respectively. Then assign a value of X to the random variable X representing the number of male kittens you receive. So you're going to complete now the table by writing all the possible outcomes and the value of random variable X. Then after that, from the value of random variable X, you're going now to get the probability, which is P of X. Then after that, you're going to make a histogram. Then consider now the following question. So you're going to answer this. What is the probability of getting more than 2 males? Less than males? Less than 2 males? At least 2 males? At most 2 males? 1 or 2 males? Then no males and all males. Again, for number 2, that is less than 2 males. Then, for activity 2, determine whether the distribution is represented is valid or not. Then you're going to explain your answer. So we have here the table number 1, 2, 3, 4, and 5. Always remember that the probability distribution of discrete random variable is always equal to 1. And before we end, let me share again this quotation according to Charles Dickens. The most important thing in life is to stop saying I wish and start saying I will. Consider nothing impossible, then treat possibilities as probabilities. Again, this is Teacher Riza saying stay safe and healthy, and please stay home. And thank you. And that's all for today. Have a nice day. Good day, everyone.